This presentation describes the discipline of characterized queues. As an example, consider the following statements that define characterized resources of type hauler. The first statement, car type, defines hauler that has several properties, the first of which is size. The rest of the properties are not listed. The second statement defines a subtype of the characterized type hauler, which has the name HBG, which stands for big hauler. The size of a big hauler is 20 tons. The third statement defines the subtype small hauler, which has the size of 15 tons. A characterized queue is a queue that can contain characterized resources of the same type. For example, the queue HQ holds resources of the characterized type hauler. It can contain either of the two subtypes of hauler, big haulers and small haulers. A characterized queue can only be initialized with resources of the subtypes of the type that it can contain. It cannot be initialized with the type itself. For example, the following statement, init HQ, initializes the queue HQ with two big haulers. The next statement initializes queue HQ with two small haulers. Each of these initialization statements adds two resources into the queue, so the queue ends up with 4 resources at the end. When a characterized resource is initialized, the resources are created at sim time equals 0 and enter the queue one at a time. The discipline by which a characterized queue arranges or sorts the resources it contains is defined by the discipline statement. A discipline statement has the statement discipline followed by the name of the queue followed by an expression. Cursoring is the same thing as pointing to a resource and then evaluating an expression. For example, the discipline for QHQ is given by the expression minus size. This expression will make larger haulers go to the front of the queue. The position of a resource entering a characterized queue is determined by the discipline expression cursored expression. The algorithm by which a queue determines the position of an entering resource is as follows. First, the queue cursors or points to the entering resource and evaluates cursored expression for that resource and then tags the entering resource with the result. For example, if a big hauler enters the QHQ, then the big hauler is tagged with that result, minus 20. In the second step, the queue cursors the resource at the front of the queue. In the third step, the queue reevaluates the cursored expression, but this time for the currently cursored resource that is already in the queue. If the result is strictly greater than the tag of the entering resource, then the entering resource is positioned in front of the currently cursored resource in queue. For example, if the hauler in the front of the queue has the size 15, it is a small hauler, then the cursored expression for the resource in front of the queue would be minus 15. Because this result is strictly greater than the tag of the entering resource, which is minus 20, then the entering resource, which is the big hauler, is positioned in front of the currently cursored resource in queue, which is a small hauler. The result is that the big hauler goes to the front of the queue in front of the small hauler. Otherwise, the queue cursors the next resource in queue towards the back of the queue if there is a resource towards the back of the queue, and then the process continues again with step 3. That is, the queue reevaluates the cursored expression for the currently cursored resource in queue, and if the result is strictly greater than the tag of the entering resource, then the entering resource is positioned in front of the currently cursored resource in queue. If there is no next resource towards the back of the queue, then the entering resource is placed at the back of the queue. This means that resources in queue are sorted by cursored expression, with smaller values placed towards the front of the queue. If there is a tie, then an entering resource is placed behind the resources that have the same value of cursored expression. For example, if a small hauler enters the queue HQ and there are small haulers already in the queue, then the small hauler will be positioned behind the last small hauler that is already in queue. The default discipline expression for any queue is time in. Time in is a property that every characterized resource has, and it contains the simulation time at which the resource has entered the queue. This means that the default discipline for a characterized queue is FIFO, first in, first out. A characterized resource entering the queue is placed at the back, that is, at the end of the queue, and a characterized resource leaving the queue or being drawn from the queue is drawn from the front of the queue. Shown below are two example arrangements of haulers in the queue HQ depending on the queue's discipline. On the left we have the default behavior, which is discipline time in. Here, resources are arranged in FIFO order, that is, the resources with the smaller time in go towards the front of the queue, and the resources with the larger time in go towards the back of the queue. This table shows the contents of the queue as a collection of records or rows. 3 fields are shown for each record, that is, 3 properties are shown for each characterized resource. The properties shown are resnum, which is the resource number, time in, and size. The resnum is a number that is assigned to each resource when it is first created. Notice that these resources have the numbers from 11 to 14. The property time in is the time at which the resource has entered the queue. The property size shows the size of that particular hauler. Notice that resources in this queue are sorted by time in. The resource with the smallest time in was the resource to enter the queue first and is in the front of the queue, whereas the resource with the largest time in was the resource that entered the queue last and is positioned at the back of the queue. Notice that these resources have sizes of different values, 15 and 20. The table on the right-hand side represents the same queue, but this time if it has the discipline property minus size. In this case, haulers are sorted by the property size, with the larger haulers going to the front of the queue and the smaller haulers going towards the back of the queue. As a result, the 4 haulers in the queue are sorted by size. In the front of the queue, we have the 2 haulers of size 20, and on the back of the queue, we have the 2 haulers of time 15. Notice that within each size, the haulers are sorted by their time in. That is, the first hauler of size 20 has a time in of 6.1, which is smaller than the time in of the second hauler of size 20, which is 8.13. So within each size, the haulers are sorted again in FIFO order, first in, first out. Notice that the first hauler of size 15 has a time in of 5.08. This was the first hauler of the 4 haulers in queue to enter the queue. Nevertheless, it is the third in line because there are 2 bigger haulers ahead of it. The second hauler of size 15 has a time in which is the largest of the group, and it is placed at the back of the queue.